Welcome to Dr. Carminati's YouTube channel. Today, we're diving into an exciting frontier of artificial intelligence. Knowledge graph-based agents for complex, knowledge-intensive question answering, specifically in medical contexts. This video aims to unravel how knowledge graphs can transform complex fields like medicine, cybersecurity, and even military intelligence. By the end, you'll understand what makes this AI tool unique, how it works, and where its impact could be felt the most. Before we begin, please like this video, subscribe for more insightful content on AI, and share your thoughts in the comments below. Your insights make these conversations richer. So, what exactly are knowledge graph-based agents? Well, imagine trying to solve a puzzle, and instead of simply having all the pieces laid out, you have a system that not only helps you arrange them, but also tells you where they fit and why. This is essentially what a knowledge graph does. It's a structured framework that links diverse pieces of information, allowing AI to reason through these relationships and draw more sophisticated conclusions. The core of today's discussion is KGARevion. This AI system utilizes knowledge graphs to tackle particularly challenging questions, the type you'd typically face in a highly specialized domain like medicine. In healthcare, for instance, queries can be intricate and layered. For example, a question might require a mix of empirical data, diagnostic protocols, and real-world outcomes, all of which need to be understood simultaneously to derive a coherent answer. KGARevion does precisely this by leveraging multiple reasoning strategies, effectively bridging gaps between disparate pieces of knowledge to form a complete picture. The process works as follows. When KGARevion receives a question, it begins by generating a series of triplets. A triplet is essentially a tiny, digestible chunk of information that takes the form of subject, predicate, object. For example, aspirin reduces inflammation. By compiling these triplets, the system constructs a map of potentially relevant data points. Next, these triplets are verified against a grounded knowledge graph. This verification step is crucial because, let's face it, not all information is accurate or relevant. The knowledge graph acts as a filter, removing noise and ensuring that only the most credible and relevant data contributes to the final answer. This multi-step approach helps mitigate common pitfalls in AI-based reasoning. Unlike more straightforward retrieval-based methods, KGARevion adapts to the nuances of medical reasoning, whether that means rule-based approaches, case-based logic, or even prototype-driven analysis. It's about robustness and adaptability, which are critical for any system trying to tackle something as complex as medical questions. All right, let's take this understanding a step further. How could knowledge graph-based agents like KGARevion be applied outside the medical context? We'll explore three areas where this technology shows tremendous promise: cybersecurity, healthcare, and military applications. Cybersecurity. In the realm of cybersecurity, information is dense and comes from diverse sources. Logs, alerts, threat reports, vulnerability databases, all of these need to be integrated to provide a comprehensive defense mechanism. A knowledge graph-based agent could excel here by acting as a central reasoning point. It would link and verify data from these various sources, identifying malicious activity patterns that traditional systems might miss. Imagine an AI that doesn't just react to a detected anomaly, but understands the context of network architecture, historical traffic patterns, and even the human actors behind potential breaches. This means quicker, more informed responses that can effectively thwart evolving threats. Healthcare. Beyond its original application, KGARevion's principles can also be extended in healthcare for clinical decision support. Picture a scenario in which a healthcare provider is faced with a unique patient profile, perhaps someone presenting rare symptoms that don't clearly fit within existing diagnostic categories. A knowledge graph-based system can reason through similar cases, drawing on both published literature and anonymized patient data to propose a differential diagnosis. Instead of merely listing diseases, it explains why specific symptoms point in particular directions, aiding healthcare providers in making more confident decisions. It's like giving doctors a peer consultation in real time, with insights grounded in data-driven relationships. Military operations and strategic analysis. Now let's pivot to a more strategic application: military intelligence. In military operations, decision-makers must sift through vast amounts of information to identify potential threats or plan effective missions. The stakes are incredibly high, and the information landscape is both extensive and intricate. A knowledge graph-based agent could analyze battlefield reports, intelligence briefings, satellite imagery, and more, integrating it all into a unified knowledge base. It could highlight patterns, predict enemy moves, and suggest optimal courses of action, allowing for rapid adjustments in tactics. In this context, the AI functions almost as a real-time strategist, augmenting human decision-makers by pulling together nuanced insights that are otherwise scattered. You might be wondering, how is this different from traditional machine learning models? Well, here's the critical difference. Traditional models often function like black boxes. They produce an output based on their training, but there's little transparency regarding how they arrived at that conclusion. This might be acceptable for a lot of straightforward tasks. But when you're making decisions involving human health, national security, or protecting vital data, you need more than just an answer. You need a reasoned explanation. You need to know how the system is connecting the dots. That's where knowledge graphs shine. By structuring knowledge in such a way that the reasoning chain can be retraced, KGARevion provides not only a conclusion, but also the roadmap leading to that conclusion. This traceability is invaluable in high-stakes environments where justification and verification of decisions are non-negotiable. Now, of course, implementing these systems isn't without its challenges. One major hurdle is the need for a consistently updated knowledge base. In fast-evolving fields, such as cybersecurity and medicine, the knowledge graph has to be constantly revised to stay relevant. Moreover, there's the matter of integration. Linking disparate databases and knowledge silos while ensuring that the resulting system remains responsive and scalable is a technical challenge in itself. But these challenges are not insurmountable. Advances in automated data integration and natural language processing make it increasingly feasible to keep these graphs dynamic. As more industries see the value in having interconnected knowledge systems, the collaborative potential of knowledge graphs will only grow. So where does that leave us today? We stand at a point where AI is becoming more explainable, more reliable, and increasingly capable of tackling nuanced, complex questions in fields that matter the most to us. From saving lives in healthcare, to defending digital infrastructure and supporting military operations. Knowledge graph-based agents like KGARevion are changing the game by adding layers of structured reasoning and transparency that traditional AI models lack. By enhancing the accuracy of answers and allowing for the explanation of the reasoning process, they are setting a new standard for what AI can achieve. If you found this topic as fascinating as I do, please let me know in the comments. I would love to hear your thoughts on where else you see this kind of technology being applied. As always, don't forget to like this video, share it if you found it helpful, and subscribe for more deep dives into AI technologies that are reshaping our world. Thanks for watching, and until next time, stay curious and keep exploring.